So today we're going to look at summarising numerical data but using the mean and the standard deviation. So the mean is used with the symbol, the X and the line above it. And in our calculators, standard deviation is listed under those stats. So remember when you put a list in list and spreadsheets, and then you do stat calc and all those and one variable, that's where you get all the data there, and you'll get like the Q3 and Q1 median. You also will see standard deviation, and it's the symbol is SX, like that. Okay, so we know that the mean is like the average, and the way we can work it out is we add them all up. So we use the mean. What we're going to start using the mean for now is we're going to have this symmetric data, which symmetric means it's following this bell-shaped curve. So we can use the mean as a measure of centre for this because of that bell shape. When we had skewed data, it wasn't very accurate to use the mean because of those outliers. Remember, they affect what the actual, it doesn't look like a true reflection of where most of the data is. So when it's skewed, we need to use the median because it's resistant to those extremes. But when we have symmetric, or another word that they use for symmetric is normally distributed or approximately bell-shaped. When we have symmetric, we can use the mean, and we're also going to use standard deviation. So what does standard deviation tell us? Standard deviation, if we know what the actual number of the mean is, if we have data, standard deviation gives us an indication of where we are in terms of the mean. So we can use that number to know, are we above the mean or are we below it, and by how far away are we, and that. And so that's what we're going to be looking at today. So as I said, they're always going to say these words like normally distributed or approximately symmetric. You might want to write that too. That's a common word they use, approximately symmetric data. So when you see these words in the question, and you'll see it, that means we're using the mean and standard deviation. So if you look here, so we've done a few examples of symmetric shaped data. So what we're saying, if we have symmetric, the mean will be in the middle and 50% would be above it and 50% would be below it when you have symmetric data above the mean and all that. Okay, so we're going to look at these things now. We're going to move on. All right, so what I'm saying here, we've got this new rule now, and this is what we're going to calculate our questions with. We've got this 68, 95 and 99% rule, and what that's with, so only with symmetric data that you can use this, okay? Only with symmetric data, so bell shape or whatever. So you can see here, and I've written in the explanation, in normal distributions, so if you go plus or minus one standard deviation. So over here, I'm going to draw a little example so you know. So I'm going to say example that the mean, I'm making this up, is 40 and standard deviation is, I'm going to say 10. So say we had some data and that was what it was. So they've said that the data is approximately symmetric. So you know you've got this bell shape. And what I just said is that the mean was 40. Okay? If I add one standard deviation to the mean, so because it was 10 in this example, if I add one, I'd be at 50. And if I take one standard deviation away, I'd be at 30. This is just this example, yeah? So if you have a look, what we're telling you, when you have symmetric data, if you're plus one and minus one standard deviation from the mean, you actually have 68% of the data lying between those numbers. So I could say in this example, 68% of the people surveyed were between 30 and 50, whatever it was. Now say I told you that we surveyed 200 people, well, then I could say if I did 68% of 200, we're going to get 136, don't we? So I know 136 people have a score or whatever between 30 and 50. So that's what you're going to get questions. Now, if you have, if we had the whole piece of data, that would be 100%, wouldn't it? If we include everything. So if I take away those middle 68%, we're left with 34 left over. Can you see that? 32 left over. So you've got 68 minus 100 would be 32. Is that right? And see how we split them in half, and you know that these little tails in here are actually 16%. So the little tail, because what was left was 32. So that's what they're telling you. So with my survey of people, I could say 16% are higher than 50, yeah? Or because I know there was 200 people surveyed, I could say 16% of 200, which is 32. I can say 32 people are higher than 50. How many people are lower than 30? 32 again, because it's 16%. So can you see, you're going to get questions like that. They're going to relate all the way to the standard deviation and the mean. So that's when you have, so this one was when you had 68%, when you had plus or minus 1 standard deviation. When we go down and we do 2 plus or minus 2 standard deviations, you can see that within plus or minus 2 standard deviations is 95%. So if I kept with my little example here, and I'm going to try it again, I'm going to do the same. So I had my mean at 40. If I go up 2 standard deviations, I'm actually at 60. And if I go down 2, I would be at 20, yeah? So what I'm saying is 95% of the data will lie between, for my example, 60 and 20, or 20 and 60, okay? So if you've got 95% sitting in the middle, then these little pockets, you've got 5% left over, so this little pocket becomes 2.5%, and this one's 2.5%. So what I could say, another thing I could say, is I could say I had 97.5% of the data was above 20. Can you see how I did that? Because I've got all the 95 plus the little the pocket. So I could say 97.5% is above that 20. So that's how, see, that's another way I could play around with the numbers. So you've got to just look at that. And the very last one is plus or minus 3 standard deviations. And when you go plus or minus 3 standard deviations, you have 99.7% of the data. Now, that is very close to 100%, isn't it? Yes, would you say? So when you go plus or minus 3 standard deviations, you can roughly say you have all the data. But they will still have little questions where they look at these little pockets, and because I'd have 0.3 left over, these little pockets are actually 0.15% each. They're very tiny. Okay, so in the 200 people, you're going to have 0.3. So if we were looking at our example, if I went plus or minus 3, so the mean was at 40, if I add 3, that would be 70, yeah? And if I minus 3 standard deviations, that would be at 10. So that's what I'm saying. So I might say 99.7% of the data lies between 10 and 70 in this example. Remember 2, got 2.5 there. What this table does is summarize it so that if we might go between certain ones. So obviously down here in the middle, that's where your mean will be. If you go up 1 standard deviation, 2 standard deviation, 3 standard deviation. And here, if I go minus 1 standard deviation, minus 2, and minus 3 standard deviation. So what I want to show you is just some examples. So if I was sitting at minus 2 and they said standard deviations, and they said how much above the mean are you, how much of the data is above you, what I would do is I go, I'm there, and I'd go like that, and you'd add up all these percentages, and then it would end up being, that one would be 97.5%, yeah? If I said, maybe they might say, another example, they might go, all right, you're 1 below, but they want you to go 3 above. So they're saying how much percentage of the data is in between that. So you add up all your percentages, whatever that is, that's 6, and whatever that one is, ends up being. So you add up all the percentages, and then you would know. So what I'm going to do is add up 34, 34, 13.5, and 2.35, and get a total. Yeah, and then I could say so much of the data is between here and here. All right. If you have a look, though, can you see when you break it up into standard deviations, can you see most of the data? How many? I've got 6 sections, haven't I? Yeah? It's broken up evenly. The standard deviation, you've got 6 of them, 6 sections there. So this is where you'll see some questions. If they ask you to estimate the standard deviation of symmetric data, so it has to be symmetric. If they ask you to estimate it, what you do is you get the range and you divide it by 6. And it's 6 because I showed you there's 6 sections. So what would the range be? The maximum value minus the minimum, and divide by 6. So you might be able to read off a histogram. You might be able to see that up here, this is an example, it might be 100, and down here your lowest one was 0. So I'd say 100 divided by 6, okay? So click that table there, see? 34%. Just before we start doing the exam questions, I just wanted to explain the Z-score. It comes up later, but I want to do it. The Z-score, what the Z-score is, it is giving how many standard deviations. So how many standard deviations, so SX, that data point is away from the, is away from the mean. So what we mean by that is if you have a Z-score, say you were part of the people in the data and you had your data, you got a Z-score of 2, that means you are sitting at plus 2 standard deviations above the mean because it's a positive 2. So that means I could say you're in the top 2.5%. Why am I saying that? Because remember, if you go plus 2 standard deviations, remember I'll quickly go, you're in the top 2.5% of the thing. If you got a Z score of, I'm going to say minus 1, you are minus 1 standard deviation below the mean because it's negative. So that would mean, so if you think about that bell shape, there's the bell shape, there's the mean. You're sitting here at minus 1 standard deviation. So I might say you're in the bottom 16%. Can you see that? Because that was one of the tails for the plus or minus 1%. That's 1 standard deviation. Okay, the pulse rates of a population of Year 12 students are approximately normally distributed. See how I said? You're going to see those words. You now know you're doing one of these questions. And soon after, they'll tell you the mean. So with a mean of 69, so I'm just going to write the X with the line above it, and the standard deviation of 4 beats. So I know my standard deviation is 4. So we're off to the question now. A student selected at random from the population has a standardized pulse rate of Z equals -2.5. The student's actual pulse rate is, so let's have a look and do what we know. So I often say if you draw a bell shape, it makes it a lot easier. So we're going to put the mean is at 69, and I'm going to go, if I go up 1, 2, 3, so one standard deviation would be 4 onto that 69, so that is 73. 2 standard deviations, I'd add another 4, which would be 77, and another one would be another 4, which would be 81. If I go down my standard deviations, I'd be minusing 4, so I'd be on 65, 61, and 57. Okay, they've said that this person has a Z score of -2, so 0.5, sorry. So they would be somewhere in here, wouldn't they? Yeah. Is that where you agree? So their score would be somewhere between 57 and 61. There should be only one possible answer in there. And which one is it? Good. 59 is the only one that's going between that category. So question 4, another student was selected at random from this population and has a standard pulse rate of Z equals -1. The percentage of students in this population with a pulse rate greater than this student. So they want greater. So they've got -1, so that's where this student is, and they want to know what's greater than that. So half is always 50%. Are you happy with that? Up to the mean. And if you remember, if you go back to that table, between the mean and -1 was 34%. Yeah? So I'm talking about, so how much greater? I'm going to say, well, it's 34 plus the 50, which equals 84%. So how much percentage was it? 84, E, sorry, beg your pardon. All right, let's move to the last question. A sample of 200 students, so now we've got an N value, was selected at random from this population. The number of these students, so be careful, they want number of these students with a pulse rate less than 61 beats. So I'll look up here, 61 is at -2, so less than 61 or greater than 73. So greater than 73 is 1 standard deviation. Now if I look, when you were at 2, if you were at -2, do you remember what this little pocket was? It was 2.5%. And what about the 1? What was the little pocket above 1? It was 16%. Okay, so really you've got, if you add them, you've got 16 plus 2.5. So you've actually got 18.5% of the 200. So what's that going to be? If you do that, it'll be 0.185 times 200, which ends up being 37. Is that correct? Okay, question 6. The time taken to travel between 2 regional cities is approximately normally distributed. There you go, with the mean of 70, so I'm going to write that's mean, and the standard deviation of 2. So I've got SX equals 2. Now, the percentage of travel times between 66 and 72 is closest to. So let's go have a look, quickly draw our bell shape and see how those numbers relate to the mean. So the mean is 70. Now, if I add 1 standard deviation, I get 72. And that was one of my numbers, wasn't it? That one. And now I'm going to go find where 66 lies. If I go -1, it would be 68, minus another 1 would be 66. So I've got these 2 pockets here. If I'm going from here up to here, how much percentage was that? I think it's the 95.5 rule, or 95% rule. So this one would be 47.5%. Yeah. So what I'm doing. So where did I get this 47 from? I've added this 34 and that 13.5. Okay. Now I've got that section. Now I want to get up to 1, and that bit was here, so it's 34. So what the percentage of travel time? So I've got 47.5% plus 34%, and what would that be? That would be 81.5. There you go, and there's your answer. Alright, going on to the next question. Question 7. The volume of a cup of soup served by a machine is normally distributed with a mean of 240, so I'm doing mean, and a standard deviation of 5 mils, so there's my standard deviation. The fast food store used the machine to serve 160 cups of soup, so I just got told the end there. The number of these cups of soups that contain less than 230. So I'm trying to find how many standard deviations is 230 away from the mean. So I've got 240. It's 5 mils. So if I go down 1 standard deviation, I'll be at 235. If I go down 2 standard deviations, I'm at 230. Now they want the numbers that are less than 230. So I'm here now, and less than would be there. So when you have 2 standard deviations less, what I'm doing, I'm up here, I'm actually doing those. So I've got 2.5% is less, but they want the number. So I've got to go 2.5% of 160, which would equal, what would that equal, guys? Okay, so that ended up being 4. To recap, which we've already done, Z-score, which we know is how many standard deviations, see, shows the number of standard deviation each data value lies from the mean in the distribution. So sometimes called standard score or Z-score. So be aware of that you could get any one of those wordings. So how you actually calculate the standard score is you get your actual value. So say this was the results over here. We can see, we'll do the examples to show you. So the mark that this is a student, and he actually got a mark of 69. So that's giving you the X. The mean of the class is given here, and the standard deviation is given there. So if I went to calculate this guy's Z-score for English, what you do is you get the actual score, you minus it from the mean, and you divide it by standard deviation. And I'm just going to end it up here. So they get a Z-score of 2.25. Okay, so we'll just write them there for a minute. So if I do the next Z-score for biology, it was 75 minus 60 divided by 5. They ended up with a Z-score of 3. The next one was 55 minus 55 over 6. Ends up a Z-score of 0. Okay, if you've got a Z-score of 0, you are sitting on the mean, which if you look at it, that person did get the mean score. So if you do the further maths, it's 55 minus 44 over 10. So I get a Z-score of 1.1. And this last one, a Z-score of 73 minus 82 divided by 4, which ends up being negative 2.25. So if you were going down to rank this person, which one's better? Do you want a positive high standard score or a negative? You want a positive because you're in the top. So if you have a look, what did he perform best? this was the best subject, and because he's got a Z-score of 3, I'm going to say he's in the top 0.15%. Okay? With this 2, which one did he come better? This is his second best subject, and because it's like 2 something, I'm just going to summarise. It's a bit more than 2, but I know he's at least in the top 2.5%. I'm using those little tails. With this he came 3rd in further maths, and because it's 1.1, I'm going to summarise and say he's in the top 16% because that's the tail for 1. With the next one where he came 4th, I'm going to say he was above 50%. So I'll spin it positively and say he was above. We could say there's 50% above him or below, whichever way you want to say. And this one is his worst subject. And because he's negative 2.25, I'm going to say he's in the bottom 2.5%. It's actually worse than that, but we just use those summary ones, yeah? I just look around on the 2 and the 3.
Okay, question 1. A student's standard mark on a class test is Z equals negative 2.1. On the basis of this score, and assuming the test marks follow a normal distribution, it can be concluded that his test was. So if we think about the bell shape, and there's the mean, and -1, -2, and -3, this guy is sitting somewhere in here. So when we had -2 standard deviations, we saw that little tail to be 2.5%. So we could say that they're in the bottom 2.5%, but not quite in the bottom 0.1, which is when there's 3 standard deviations. So we'll go with that answer. In question 2, we have a student's standardized score is Z equals negative 1.2. The mean mark was 55 and the standard deviation was 2.85. Their mark on their test was closest to. So if you think about it, the Z score equals the actual minus the mean over the standard deviation. I could say negative 1.7 equals, I'm trying to find their actual score, minus 55 over 2.85, and I can just do solve on that and comma x, and I'll get what their actual score is. So I get that to be 50.2, so I'm going to go with B. Okay, in the next question, the weights of the male players in a basketball competition are approximately symmetric or distributed. So that means in the bell shape, with a mean of 78.6 and a standard deviation of 9.3. So there are 456 males in the competition, so we just got given an N there. And they are expected that the number of players in the competition with weights above 60 kilos. So we've got to try and find where that is on our curve. So we've got a mean of 78.6. If I go down 1 standard deviation, I would be at 69.3. If I went down 2 standard deviations, I would be at 60, so that's where we're looking at. The expected number of players with weights above 60, so I know that we're at 60 now, which is at 2 standard deviation, so I want to go above. So in 2 standard deviation, this little pocket here is 2.5%, so I pretty much have everything but that 2.5%, which would then lead to be, I've got 97.5% of the 456 players. So if you do that, we end up with 445. Okay, and now this last one. Brett and Sanjeev both play basketball. When the weights of the players in the competition said Brett has a standardized weight of 0.96 and Sanjeeva has a standardized weight of negative 0.26. Which of the following are true? So sometimes I think still be better if you draw a little diagram and work out where these people are. So if I go -1 and then -2, standard deviation. So if I go to Brett is negative 0.96. So he's nearly here at 1. So there's Brett. And if I do Sanjeev, whatever his name is, he is at negative 0.26. So he's more closer up to the mean. Alright, so this might help me answer these questions. So if I have a look, Brett and Sanjeev both below the mean. So we're looking, for which one's not true. So Brett and Sanjeev are both below the mean weight for the players in the basketball competition. That is true. Sanjeeva weighs more than Brett. You can see the S is higher up on the scale. So I'm going to say that's true as well. If Sanjeeva increases his weight by 2 kilograms, he would be above the mean weight for players in the basketball competition. So what we want to do, if we want to probably see how this question are all related, so we can actually find Sanjeeva's weight if we want to, because Sanjeeva has a Z score of negative 0.26. So I could go negative 0.26 equals his actual minus the mean, which was 78.6, divided by standard deviation. So I could actually find out what Sanjeeva's weight is by solving that. So I'll do that. Okay, so Sanjeeva's weight is 76.18. Now they said if I add 2 kilos, would he be above the mean? That would make him 78. It would make him 78.18, which is still just below the mean, which we said was 78.6. So if you increase that, would he be above the mean? That is not true. So I'm going to go with this as my answer.